class, we're going to finish off 5.2 on page 6 of the notes. We've got some what are called Pythagorean identities. So we're building our list of identities for this class. These are some famous ones, and we use them a lot throughout the semester. So there they are. Sine squared plus cosine squared is equal to 1. And then there's some variations of that one below. But where do those come from? I can go down onto a blank page and show you why those are true real quick. It really is just the Pythagorean theorem. Let's think about just being in quadrant 1 on a right triangle where the vertical is y, the horizontal is x, and the hypotenuse is r. I know that we have x squared plus y squared equals r squared. Okay, Pythagorean theorem. Now, think about what would happen if we just divided everything by r squared. That's legal, right? Divide everything by the same value. Now, x squared over r squared is x over r squared. Y over r squared. R squared divided by r squared is 1. Okay. Now, think about your trigonometric definitions. You should start recognizing x over r. X over r is that cosine ratio. So if theta, this is theta right there. This would be cosine of theta squared. That's sine of theta squared equals 1. Okay, and that's the identity. Now, there's a notation that's used in trigonometry. If you have a power of a trig function, you actually don't use the parentheses like that. You just put the power there. So but this cosines, these mean the same thing. So if you see this second one over here and it looks confusing, think of it that way, right? And that's sine squared equals 1. And then you can interchange cosine and sine. It doesn't matter which one goes first. It could be cosine squared plus sine squared or sine squared plus cosine squared. Addition is commutative, doesn't matter which order you add them. Okay. So that's how that first one comes about. Now, those other ones, take that one, and one thing you could do is just divide everything by cosine squared. Right. And then cosine squared divided by cosine squared is 1. And then we'll see that sine over cosine is actually tangent. I guess I should have shown you that one first. And then 1 over cosine is that reciprocal identity. 1 over cosine is secant. All right, so 1 plus tangent squared is equal to secant squared. That's this one right there. All right. And then you can get this one in a similar way by just dividing everything by sine squared. Okay. And then we have those quotient identities. Tangent is sine over cosine, which that makes sense because sine is y over r and cosine is x over r. And if you do some algebra there, the r's are going to cancel and you end up with just y over x. Okay, so that's really the reason for that one. Cotangent is the reciprocal of tangent, so just flip it over, cosine over sine. Okay, so these identities will be useful in problems like the last two that we did. We could have used identities as opposed to drawing out the triangles. Or we can do a new one like this number 27. Try using these identities to find all of the remaining 6 functions of theta, given that cosine theta is -1. Okay, so let's see if we can do that. And we're just going to use identities, right? One thing I can look at is this first identity. If I know cosine, I can find sine with that identity, right? So I would have sine squared plus cosine squared. I'm going to replace cosine with -1 equals 1. Okay, so then I get sine squared, -1 squared is +1. Subtract the 1 over, you get sine squared equals 0, right? And then if you square root both sides, if sine squared is 0, then sine is 0. Okay, so the sine is 0. When cosine is -1, the sine is 0. Once you know both sine and cosine, right? So we know cosine is -1 and sine is 0. Well, then we can use this to get tangent, right? So tangent theta is sine over cosine, which is 0 over 1, sorry, -1, which is 0. Right, so tangent theta is 0, right? Okay, and now we have cosine, sine, and tangent. The other three are the reciprocal identities. So now just flip them all over. So secant is the reciprocal of cosine. So if cosine is -1, secant is 1 over -1, which is just equal to -1. Cosecant is the reciprocal of sine. So if sine is 0, cosecant is 1 over 0, undefined. And then tangent is 0, so cotangent 1 over 0, again we get undefined. Okay, so there's a way to use those trigonometric identities to solve a problem like that. Pretty useful. And that's the end, 5.2. We did it. All right, 2 sections down, 1 week of material completed. So hope it's going well for you. Again, any questions at all, send them my way. Email is best. I'll respond as soon as I can, usually pretty quickly. Okay. Hope all's well. Talk to you later.